Alright, diving back in, 10 seconds after. Did we totally just screw ourselves by doing what we did? I don't think so. And the reason why is because when we reassigned this second value, it did some dynamic memory allocation and shuffling and shit behind the scenes. I think that if we go back, if we shut this down and we restart it, and then we assign a new value, to the first variable, whatever we assign to that first variable is going to show up out here. Why? Because our mission statement from the very, 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 very beginning of this sort of pointer adventure series here was to find the value of the first variable that we declared in this interpreter in a dynamic way. So what happens after we assign a new value to it? This variable gets some new memory location. So what's all this crap over here? This is probably just some random dumb shit that the memory manager of Python and the black box and black magic and all that. It's just some bit pattern it's dumping into stuff. So that's what I'm gonna hope, and that's what I'm gonna assume. So we're gonna close this. This is not attached. It has no value. Fire it back up. If this does not work, then I'm gonna be in real trouble here, and I'm gonna probably just shut this off. Will I upload these videos? Absolutely, but I'll probably just shut this off and go cry in the corner. So we're gonna make it holy crap or holy shit, please work. And we're gonna make it 192895. Nothing changed, and the reason why is because we haven't attached to a process yet. So we're gonna go here. We're gonna click here. As soon as we click open, it's gonna ask us if we want to keep the address list, but these should immediately populate over here. If it doesn't, then we're gonna know that we failed, and it's gonna be a real problem. There you go. Thank fucking God. uh, am I, flying by the, am I like really talking on my dad? Like, oh, how does he know that it's not sure it works? Because this is 5 levels of indirection. And there's just, again, I made this up off the top of my head. There is so much black box crap going on when it comes to Python that these rules of assigning memory locations, when you do a reassignment and things like that, do I know that because I, dug out the source code to the Python interpreter? No, this is something that I am just sort of, am I making it up? No, but I'm certainly, uh, I am deducing these sort of facts just based on what I think I know about memory management in general. So, thank God that we didn't screw ourselves by doing that, because again, it's never cut and dry when you're dealing with this stuff. Have, I programmed for over a decade, and I'm still, when I get into this kind of crap, I'm always just a little bit unsure about, if I start seeing crazy results, or I, start doing something like this and reassigning value, in a situation like this, if I start reassigning values and I lose everything over here, do I immediately think, well, I don't know what the fuck I'm doing? No, I don't immediately jump to that conclusion. But what I do immediately start thinking is, so there may be something that I don't know that is going on here, because there are so many subtleties as far as, what is the platform I'm working on, what is the middleware I'm dealing with, what are the offsets. There are so many layers of abstract, not just the 5 levels of offsets with pointers, but there are so many abstractions that exist as far as the OS, all the way, or from the level of the OS all the way down to the processor. There are not defined amount of layers of abstraction. It depends on the application you're running. It depends on how you're dealing with this stuff. If you are messing around with pointers, 5, 10 levels deep, something like that, screwing around with memory addresses, and you never have any like bead of sweat on your forehead, then you are a much better man than I, or a much better person to be gender neutral about it. And that's all I can really say about that. I mean, this is just a fundamentally complex concept, and this is the easy way, quite frankly. Using the pointer scanner is, removing so many things that we have to deal with. Um, that just imagine what we're going to start doing when we jump into the sort of, quote unquote, the manual way, which is where we're scanning for memory addresses. What does it mean to do it the manual way? What it means is you're putting memory addresses over here, like, and take this as a example. You're putting memory addresses like this in the value box. You're checking hex. You're making sure the value type is, somewhat, relative to the platform you're running on, and then you're scanning. memory locations for memory values, or you're scanning memory locations for values based on the actual address that they point to. Is that easier or harder? It totally depends. If you're dealing with, sort of like lower levels of indirection, then doing that kind of scanning is sometimes faster, sometimes easier, sometimes more comfortable. Some people prefer it, but when you get into stuff like this, and again, this is, using cheat engine on a Python interpreter, I've never seen any video where people start screwing around like this. Did we do it because, oh, we want to say we're awesome? No, it's absolutely not why we did it. We did it because I knew there was going to be multiple levels of indirection involved with Python, because I just sort of know how Python works under the hood, and I thought, one, it's fun. And as soon as I end this video, I'm gonna sort of drink a couple beers, and sort of salute myself, because I think this is awesome, and I had a lot of fun doing it. Even though I sweat a little bit, I had a lot of fun doing it. But so let's sort of stop talking about that, and it's get into one trick. We're just gonna go over one trick real quick about how we can cut down the results for the pointer scanner. We talked a little bit about, you could restart your computer, you could do some things like that. That's great. Before we do that, let's just set this to 1, 2, 3. If these all change, well, we know why they all change, because we have a new memory location associated with this variable. That new memory location associated with holy shit, please work has some series of offsets that is different than what we have here. So just to sort of, we'll close this and open it up real quick, and we'll get into why you don't want to restart, or you don't want to close and restart applications this fast. We're just going to say x equals 5. As soon as we hit enter, everything over here is going to, nope, it's not going to do it yet. We have to associate it with the process first, so it scans the memory. It's got some spurious values over here. As soon as we hit enter, which is literally going to be in 20 seconds, every single value over here is going to change to 5. Otherwise, my name is not Patrick. Oh, that's a real problem. Really? Son of a bitch. We're going to close it. We're going to open it back up. It's possible we just fucked this all up. Think about this. Do that. Maybe we just attached it to the wrong process that time. That's what we're going to say. We're going to go down. Python W. The second process. We're going to do that. Some value. Really? Equals 1, 2, 3. Fuck. Well, anyway. What are we going to say about that? I don't know. Kind of messing around with it now. Apparently my name is not Patrick. Let's go here. Let's do that. No, that's definitely not what we want. I don't know, let's set this, no, let's close it. Let's fire it back up. This is a real problem. Yep. Do a bit of that, a bit of this. We get the same sort of spurious values we got. Let's name something weird. What the hell? 593 or 283. Alright, it's working now. Seems to be working now. So what's going on here? That's a good question. There's probably a lot of things that are going on here. It's possible, again, that we were sort of attaching it to the wrong process. It's possible that the memory got juggled around in a different way. As far as the absolute value, you can see this all changed relative to what we did in Cheat Engine. We could ask it, what the hell? What is the value of what the hell? It says 55. So what just went on there? Well, it's always tricky. This is just sort of an A side what I'm gonna say, and then we'll get into the trick that I was talking about. Does what just happened immediately invalidate everything we did? No, but what it does is it proves the point about how you always have to be careful with doing these kind of things, and assuming you have the right results. When you're done testing, test some more. When you're done testing, test some more. When you've done those tests, test some more. Restart the application, restart your computer, restart the applications on your computer. Don't just restart the game or the Python interpreters. It may be, restart everything on your machine, and that's kind of the trick we're going to sort of get into here. So, um, is this going to work every single time? I don't know. I mean, again, there is so much going on under the hood here that we're just going to sort of say, I mean, here's what we're going to do. We're going to leave this open, but we're going to minimize it. We're going to add, when you double click on something over here in the pointer window, we'll just double click on something else. It immediately adds it over here to the address value or to the address list. We can delete the record. It doesn't matter. It's still going to be over here. So what we're going to do is we're just going to add the top one. We're going to minimize this. And what are we going to do? We're going to close this. We're going to leave Cam Studio on, obviously. We're going to leave Cheat Engine on, obviously, because if we close it, then we'll lose this all this crap down here. We could reopen it by the pointer scanner and go to open and choose last one, but we're not going to deal with any of that. So what are we going to do? What is the trick that we were talking about? Well, the trick that we were talking about is that operating systems in general, their memory managers and whatnot, they sort of have a habit of sort of caching different things and loading things into the same memory locations and whatnot. So one way that you can sort of trick your computer into really screwing around with the memory, it's not even tricking the computer, it's just taking advantage of the fact that how memory managers work. So you can bring up applications that you've had minimized. You can go to YouTube. You could watch some videos. I don't know. We'll do that. We'll go to the Brick Tamlin compilation because I was looking at some Anchorman stuff. Do this. It's streaming video. It's obviously allocating memory to deal with the memory frames. We'll click on this teleprompter. We'll click on Will Ferrell. We'll click on another video. Okay, that's it. We'll close this tab. Then we'll open up another tab, another tab, another tab. We'll close these tabs. Every time we do stuff like this and force the computer to sort of allocate some stuff or to take some action and deal with some results and some content, it's allocating memory and deallocating memory behind the scenes in a very rapid fashion. So when you do things like that, what else can we do? We'll fire up Chrome. Are we going to browse around with Chrome? No. We're just going to do that. We started it, it allocated memory. We closed it, it deallocated memory. So we have sort of really juggled behind the scenes, the addresses that the OS is dealing with, and there's all sorts of complex algorithms that go on to sort of, figure out efficient ways about, smallest fit, largest fit, things, stuff like that. So what are we gonna do now? Well, now we're sort of done forcing the OS to juggle memory around things like that. So this, by the way, this is an alternative to restarting your computer. That's probably the best thing for you to do, but this is also a very. I find that 6 out of 10 are we going to be that specific. That a large majority of the time I can use this sort of trick to juggle memory around and not have to restart my computer and deal with that sort of nonsense. So we got Cheat Engine open. We'll open this. That's not what we want to do. We just want to bring it back up. There we go. All right. So we're going to attach Cheat Engine back to this process. Again, we've juggled all sorts of memory around. Keep the current address list, code list. No. Yes, actually. And then we're going to do that. And we're just going to say some freaking variable. No, we're going to call it Brian the dog. Because I love Family Guy. Equals 54321. You can see down here, this value has nothing. And this value, this pointer, has a value of 54321. Let's take the last little bit of time we have. You can see it's a P, has a hyphen, right arrow, points to some absolute address in memory. We, kind of want to make the point here. We could do two things. We're going to go to add address manually. We're not going to do a pointer or anything like that. We're simply going to do 22A, A51A8. Going to hit enter. You can see they have the same value. We're going to change this non-pointer value to 50. We're going to go back to Python, tell Python, evaluate that variable. It is 50. You can see that the logic of the pointer is pointing to an actual memory location in memory. We just add that manually. We get that memory location. We change the value. It is immediately reflected in Python. Now, what else can we do? We're going to double click here. All right, the next video may be short, but we're going to jump into that.